Good morning or good afternoon. It's Miss Bauer here, and today we're going to talk about polyhedrons. So I have two pictures here. I have some pictures that have polyhedrons and some pictures that are not polyhedrons. And if we kind of go through and take a look at these shapes, so this shape right here you probably have seen before. This is a rectangular prism. Named after its base, which is a rectangle. This right here, so it comes up to a point, that would be a pyramid, and then that base would be a square pyramid. This is a polyhedron. This is a special type of polyhedron that we won't actually discuss in this geometry class, but if you get into more advanced mathematics, then you'll take a look at some really intense polyhedrons like that one right there. And then these are not polyhedrons. So if you know the name of this, awesome, that's a cylinder, spelled with a C, not a S. This right here, I'm sure you've seen before, that's a cone. And then this last one is a sphere, spelled S-P-H-E-R-E. So if we take a look at the ones that are polyhedrons and the ones that are not polyhedrons, well, we can see that they're all 3D figures, but the polyhedron is made up of polygons, which have straight edges. So a polyhedron is just a 3D figure made up of polygons, which have straight edges. Now, this unit isn't just about polyhedrons. This unit is about all 3D shapes. So we're coming out of 2D shapes. We're coming out of polygons. We took a look at quadrilaterals, pentagons, all of that. And now we're going to get into 3D shapes. And today we're going to talk about how are 2D shapes and 3D shapes related. So the first way that 2D shapes are related to 3D shapes is what's called a net. A net would be like if I had a cereal box and I kind of flattened it out or cut it up. So I would be able to tell like there's 4 sides and then there's like the top and the bottom. It's almost like origami. Like a net is the 2D version of a 3D shape. So make a note of that if you need to. But the net is just the flattened out 2-dimensional version of a 3D shape. So for example, if we look at a cylinder, well, a cylinder is one giant rectangle and then it would have the circles to create the bases. If I were going to look at a pyramid, well, a square pyramid would have a square base, and then it would have a lot of triangles, and that's the net. So the first way that 3D and 2D shapes are related is with nets. The second way that polygons or 2D shapes are related to 3D figures is by rotations. If you took a quarter or a penny or any type of coin and you spun it really, really quickly, well, it doesn't look like it's a circle anymore. It would look like it was something else. So think about that. If you took a coin and you spun it around really, really fast, well, it wouldn't look like a flat circle anymore. It would look more like a sphere. And there's all sorts of different shapes that we could spin that create 3D shapes. So taking a look, let's look at this rotation right here. I have a rectangle. And as I'm spinning it around a y-axis or a vertical line, it turns into like a paper towel roll. So I had a rectangle. I'm going to play that again. I had a rectangle, and if you notice there's a gap between the point of rotation or the line of rotation. If we moved it a little bit closer, we would have a cylinder, but in this case, if you spin a rectangle, you end up with a cylinder or a paper towel roll. So we could take a 2D shape and rotate it or spin it very, very quickly, and we'll create a 3D shape. The other way that polygons are related to 3D figures is by what's called a cross section. And a cross section is if at any moment we decide we're going to slice a shape and we're going to look at it from a different angle or from a bird's eye view, well, if I look at that 3D shape would look 2-dimensional based on the cross section. So we'll go and talk about all of those in detail in a little bit, but first let's take a look at some 3D figures and see, do you know your shapes? So this 3D figure right here, I'm going to go ahead and put ticks on it, and maybe I'll make it a little bit clearer what it is. Well, this wouldn't be a rectangular prism. This would actually be a cube. And all of our 3D figures rely very heavily on what shape the base is. So in this case, all of the sides are all what? Think, what is a cube made up of? And that would be squares. Now, prisms have, a cube is just a square prism. So if I ask you how many bases does it have? Well, it has a top and it has a bottom. So this would have 2 bases. Think of it like a prism, and prisms are connected with rectangles. Like think of the classroom. There's the floor and the ceiling, and then we connect them with the walls. Okay, faces would be how many flat surfaces does it have? So the face is just how many flat surfaces does the shape have? And if you think of a dice, or think of the classroom even, there's the floor, the ceiling, that's 2, plus the 4 walls, so that would be 6 faces. And because it's a cube, all of our faces here are all squares. Okay, so the edge is where the faces meet. So if I asked you to count how many edges does this have where the faces meet, so that's an edge right there. So I'm going to give you a minute to kind of count and see how many you get. I kind of like to draw over them. I think it makes it easier. Well, there's 12 edges. So the edges are where the faces meet. And then there's one more thing that we're going to add in here, and that's going to be vertices. Your vertices are the points where the edges meet. So edges are where the faces meet, and then vertices are where the edges meet. So it'd be like these corners right here. So if I count really quickly, I have 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8 vertices. Now, taking a look at the next one, this is not a prism. If it comes up to a point, that's a pyramid, but they're always named after their base, so we're going to call this a square pyramid. If I asked you how many bases does it have, well, a pyramid only has 1 base. And the shape of that base is a square. We always name our shapes after their bases. So I have 1 base, that's a square. If I asked you how many faces there were, how many flat surfaces are there? Well, I have the 1 square base, and then I have my 4 triangles on this side. So I have 5 faces total. I have my base plus my 4 triangles on the side. And what are the shape of these faces? And I'm going to add in this word lateral up here. Lateral means what are the shapes of the sides that are not bases? So like the base is a square, but what is the other side that we see? Like what is the other shape? Well, that's a triangle. So just kind of a heads up, pyramids should have lateral faces that are triangles, and prisms will have lateral faces that are rectangles. That's a very quick way to check, is if it's a pyramid, your lateral faces will be triangles. If it's a prism, then your lateral faces will be rectangles. And feel free to take some extra notes on this as you're going through. If I say something a few times and you want to write it down, that's always great. Okay, edges. If I start counting, so if I just count 1, 2, 3, 4, and then I have 1, 2, 3, 4, that makes 8 edges there. And then if we count our vertices, or the points where the edges meet, well then that would be 5. Now this next shape tends to confuse people. Like these next 2 shapes, people tend to trip these up and they get these confused. Okay, if it comes up to a singular point, that's a pyramid. So this one right here, this is a pyramid. It comes up to a singular point, so that's a pyramid. Okay, this does not come up to a singular point, which makes this one a prism. So now I just need to figure out, well, what type of pyramid, what type of prism. So in the pyramid, they're always on their base. So if I look at the pyramid, that's a triangular pyramid. And prisms can be a little bit confusing because prisms should be 2 bases. So a prism has 2 bases while a pyramid has 1. And prism has 2 bases connected with rectangles. So what is the shape that we only see 2 of? Well, I only see 2 triangles, and those are connected with rectangles. So this would be a triangular prism. So what's the shape of the base? Well, they're both triangles. if we go through, well, how many faces does this one have? So think, I have the base, and then I have a triangle on each side, so that would be 4 faces total. And if it's a pyramid, remember those lateral faces, all I have in that shape are triangles. If we count the edges, so there should be 6. And then if I count the points, well, then there's only 3. Vertices, I mean 4. So for a triangular prism, I have even more faces. So I have my 2 triangles on the end. I have my 3 rectangles that connect. So that would be a total of 5 faces. And then what are the lateral faces? Well, the triangles are the base. What connects them are rectangles. We said rectangles. Prisms have more rectangles. Okay, edges. If you just literally trace, I'll give you a minute to count the edges and the vertices, and then we'll see if you're right. And hopefully you got 9 edges and 6 vertices. Now, there's this guy, this looks like Euler, but it's actually pronounced Euler. So Euler's theorem says that if you take your number of faces and add the number of vertices and subtract the edges, regardless of the shape, you will always get the exact same number. So we're going to do that. So we're going to add the faces and the vertices, and we're going to subtract the edges, and we should always get the same number. So 6 plus 8 is 14. 14 minus 12 is 2. The next one, if I add the faces and the vertices, so 5 plus 5 is 10. 10 minus 8 is 2. 4 plus 4 is 8. 8 minus 6 is 2. 5 plus 6 is 11. 11 minus 9 is 2. So Euler's theorem is just a way of checking it, that the faces plus the vertices minus the edges will always equal 2. And feel free to add that to your formula chart. So that's one that I would add to the formula chart. Now, knowing what these shapes are and what shape your faces are and your bases are really helps you whenever you're determining other parts. So if I asked you, how many different ways could you slice this cone with a plane? So like if I asked you, like, how many ways could you slice this cone and what shape would you get? This is what's called a cross section. And knowing some things about a cone, like a cone has a base, that's a circle. So surely there's a way that I could slice this that would give me a circle. If I slice it vertically, if I look at it cone, I see a triangle. So there's a circle, there's a triangle. Then we're going to watch a quick little clip to see what other options do we have.
Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the
So from that clip, if we go in at an angle, well, we saw it wasn't a circle, it was more of an oval. And then if we slice it this way right here, then we'll get this kind of curved shape. So I could actually slice this cone 4 different ways and get 4 different shapes. Now, in a problem, they'll typically tell you how to slice it, and then you just have to determine the shape. So taking a look, we have some shapes here, and we're going to go ahead and cross-section, so slice them. This one says if we're going to go parallel to the base, so horizontally, well then really just ask yourself what shape is the base. And if we were going to have the cross section horizontally, well that would create a triangle. If I take a look at the next one, if I have that same shape, triangular prism, but now I go vertically, so perpendicular to the base, well, those lateral faces were rectangles, so this would give me a rectangle. Also think of this like if you have a slice of cake and you slice it, well, then you don't end up with like a triangle anymore, you end up with a rectangle. So this is a very, very visual. You really have to picture, like think like you have a block of cheese in that shape. And if we slice it parallel or horizontal to the base, well, then what shape would we see? This one would be a triangle. So it really does revolve around which way you're slicing it and how you're looking at that shape. So we have a cylinder right here. If we go vertical, so perpendicular to the base, I'm going to give you a second to think about it. Think of like Lysol wipes. If we sliced it down the middle, what 2D shape would you have there? That would be a rectangle. And then if we went horizontal, that would be a circle. Hopefully you're starting to pick up on some patterns here. And then if we have a cube and we go vertical right there, well, I would end up with a square. Just like that. And if I had a cube and I took a corner off of it, well, a corner might end up with a triangle. Or if I slice a corner off, if I go in at a weird angle, I could end up with almost like a trapezoid, depending on how I slice it. So 2D shapes are related to 3D shapes by different methods. Cross sections is just one of those ways that 2D shapes are related to 3D shapes. Okay, now let's talk about changing dimensions. So as we get into those next few days talking about surface area and volume, we could talk about changing the dimensions of something. So for example, let's just say that you're a company and you have a container and you want it to hold 4 times the amount that it does. Well, then you're going to have to change the dimensions. You're going to have to go backwards. If you want it to hold 4 times the amount, you're going to have to figure out what do I need to change the dimensions by. Because chances are if you increase your dimensions too much, well, then your volume's going to increase too much. So if we have a rectangle that has an area of 25 feet squared, and they decide that we're going to half the length and quadruple the width, well, what would be the area of the new rectangle? How would that affect it? Well, this goes back to those formulas that we've talked about before, the PAV 1, 2, 3. Remember that our perimeter will just have one change, so it'd be the original times the change. Area will have the original times the change times the change. Keeping in mind that your changes don't have to be the same. If you're going to renovate something, you might want to half the length and double the width. Or maybe you want to double the length and triple the width. Your C's don't have to be the same amount. They probably wouldn't be in real life if you were doing something. And then for volume, with units cubed, we have those changes 3 times. So I would also add these to your formula chart. And let's take a look back at this problem. So the rectangle has an area of 25 feet squared. So that's my current area is 25 feet squared. Well, I'm going to half the length. So if I'm looking at area, that's one of the changes would be half. And then I'm going to quadruple the width. So quadruple would be 4. Well, half of 4 is 2. So 25 times 2 would just be 50 feet squared. And that would be how the area is affected. It would go from 25 to 50 feet squared. It would actually only double because the length was halved and the width is quadrupled. So taking a look at a cylinder, so now I have a 3D shape that has a surface area, still area of 144 centimeters squared. Well, the height is divided by 3, the radius is divided by 3, and the height is divided by 4. Find the new surface area. So still, once again, going back to area, so taking a look, my original area, or surface area, is 144. Well, they said that we're going to divide it by 3, and we're going to divide it by 4. So we actually don't really need a calculator by this. If you divide something by 3 and 4, really you're going to take the value and you're going to divide it by 12. So what's 144 divided by 12? Well, my new area would shrink big time. It would go from 144 centimeters squared to only 12 centimeters squared. And taking a look at the volume one, a pyramid has a volume of 107.5 inches cubed. Okay, we're doubling the length, we're tripling the height, but the width is remaining the same. So if I go back to this volume one up here, volumes have 3 units, which mean 3 changes. So my original volume is 107.5. Okay, I'm doubling the length, so I'm going to multiply it by 2 for that. I'm tripling the height, so I'm going to multiply it by 3 for that. And then it says, but the width is staying the same. Well, that would just be a 1. So what's 2 times 3 times 1? I'm just going to take that volume and multiply it by 6. And so my new volume would be 645 inches cubed. And that's how that volume would change. So as we progress throughout these problems, talking about surface area and volume, don't forget that whenever they talk about changing the dimensions, you really have this shortcut. I don't expect you to go back and actually double the length and triple the width and all of that and do the work again. Remember that everything's related, so we have these formulas that we can use to figure it out. Now, for today's practice, all that you're doing is figuring out what formulas would you use on some of these problems. So, for example, if you had a rectangular prism and you were finding the surface area, well, the surface area formula for a rectangular prism, if you go take a look at your formula chart, that would be S equals PH plus 2B. Now, it's a rectangular prism, and B stands for area of the base. So all that this is saying is to find the formula for B, how do you find the area of the base? Well, if it's a rectangular prism, the area of the base would be an area of a rectangle. An area of a rectangle would be base times height, but we're going to replace that A with a capital B. And that's it. So on this practice, all that you're simply doing is finding the formulas. No need to solve, no need to do any of that, but you do need to remember what shape is the base and then how do you find those formulas.